Well, thank you, Neil. And as Neil mentioned, SkillBoss Logistics is the device for assessing the hands-on skills in the CT-SCA certification. Everyone who gets certified has to test out on this device to ensure that we have consistency in the evaluation. The ultimate goal, of course, is to ensure that individuals can actually do the tasks they'll be expected to do on the job. SkillBoss also has a second purpose, and that is to serve as a training device to enable individuals to learn the skills on which they'll be assessed. The development of SkillBoss has been an extensive process, and in fact, it's taken about 2 years. But I can truly say it's been a team effort, and we've had leadership from 5 key organizations, including those that you see here, which are some of the ones that Steve and Neil mentioned: the National Center for Supply Chain Automation in California, MSSC in Virginia, the Material Handling Equipment Distributors Association, or MHEDA, in Illinois, the Material Handling Institute, MHI, in North Carolina, and finally Amatrol in Indiana. And this group not only created the vision for the device, but also played a key role in engaging industry experts from the memberships of MHI and MHEDA and their many industrial contacts that they had across their network. And so we ultimately assembled a who's who of the supply chain industry with some iconic names. Some of the ones that Steve already showed you were companies that got engaged in the development of the SkillBoss device, and they provided expert advisors to shape the design of SkillBoss and the skills it addresses. And I can't thank the companies and the people that participated in the process enough for what they did, because they spent countless hours reviewing and testing ideas and finally prototypes, and even coming in for several weeks at a time to test the device and make sure it actually did what we intended it to do. So the result was the device that you see in the lower left-hand corner of the slide here, and it's a working tabletop size sortation system. And even though it's compact, SkillBoss uses the same technologies and techniques used in large-scale sortation systems, like the systems that you see on the right side of this slide. And it was really quite a challenge, because to bring the size of these systems down to something that could fit on a tabletop and not lose the industry feel of it, there were a lot of special components that we had to source, and even some that we had to make from rollers and other devices, and they're just pieces that aren't made in that size. But our designers were able to accomplish that, and the help that we got from the expert advisors really made a difference. So on SkillBoss, packages are inducted, scanned, routed to multiple conveyors, and then sorted into 3 destination chutes. And if there's a bad scan, they're sent to a rework station. And the skills that students learn on the system or assessed on are not only applicable to sortation systems. We also made an extra effort to include a wide range of technologies on SkillBoss to make sure that what students are learning and being assessed on applies not only to sortation systems, but other types of supply chain automation. The skills that the students learn on SkillBoss are aligned with 3 CT-SCA certification tests, which Neil listed here shortly before. And to learn the skills, we've developed 3 online courses. And as you see here, the courses are titled the same as the certifications. Course 1 is equipment maintenance. Course 2 is equipment repair. Course 3 is network repair. So these courses not only prepare individuals for the CT-SCA hands-on assessments, they actually prepare them for the online certification test. And each course is about 150 hours, which includes the time to learn the multimedia content and also to do the hands-on skills on SkillBoss. This next slide shows some examples of some of the screens from the online courses. And as you can see, they're truly multimedia courses with animations, 3D graphics, voice and text, and also they're highly interactive. They're not just page turners. The courses have also been designed to specifically focus on the technology of supply chain automation. And this means students can go through these courses faster than if they were taking traditional maintenance courses that are being offered by many colleges across the country today, which might have similar content, but they cover more than what's needed for the supply chain industry. And I think this feature makes these courses ideal for workforce development and in-plant training, where the learning time is critical. The courses also feature simulators, so students can practice the hands-on skills online in addition to using SkillBoss. And this slide shows some examples of our simulators, which cover fundamentals such as electricity, motor control, pneumatics, and PLCs. We call these simulators virtual trainers because they allow individuals to perform the same skills they would perform on actual industrial training equipment. What makes them special, though, is that, and I think makes them more realistic, is that we have designed them so they have all the same behaviors that the actual devices do. So when students are hooking up circuits or writing a program or making an adjustment, they can make the same mistakes in the virtual trainers as they would on the real equipment. So they get to see the results and learn from it. Once students have learned the concepts through the online courses and virtual trainers, they're ready to practice their skills on SkillBoss. And the hands-on learning, I think, goes a lot quicker as a result of having gone through these virtual trainers. So we've developed approximately 100 skills that align with the CT-SCA certification that we can perform on SkillBoss. They're organized into the 3 groups that align with the 3 online courses, which align with the 3 certifications. So in course 1, individuals practice skills such as system operation, safety, preventive maintenance, lubrication, and machine adjustments. Those are all the entry-level skills that somebody would perform if they're coming into an entry-level maintenance type of job. In course 2, they start to learn about installation and troubleshooting, focusing on the electromechanical devices, which include things such as fluid power, DC and AC motors, mechanical power transmission. And then finally, course 3 is the capstone, and it really is the companion to course 2 because there they add a learning of installation and troubleshooting of controllers, networks, scanners, and really work with the entire system. The components of SkillBoss are contained in 3 major elements that you see here. There's an HMI, which runs a warehouse control software, which people in the industry call a WCS. There's a control unit with a PLC, Ethernet network, and a variable frequency drive, as well as other electromechanical components. And finally, the workstation itself, which includes multiple types of conveyors, sensors, actuators, and a barcode scanner. So all these elements work together to recreate a sortation system just as you would find in a distribution center. To go a little deeper, this layout shows the components as they are arranged on the workstation. And I know there's a lot to digest here, but I'll just walk you through it. The packages enter the system at an induction roller conveyor shown in the lower right corner of the slide here. And this conveyor queues the packages up for the system and then acts as a metering device to control the package gap. Packages are then transported to a second conveyor called an induction belt conveyor, and its function is to actually pass the packages through a 2D barcode reader. If the package scan is bad, there's a vertical sorter conveyor located just to the left of the induction belt conveyor, and it actually lifts up and passes the package to a recirculation conveyor located on an upper level. Packages on the recirculation conveyor stop at a rework station where a problem can be corrected, and then the package is released and it's passed to a gravity slide, and it slides back down, rejoins the induction belt conveyor, and goes back through the barcode scanner again. If the package scan is good, the vertical sorter remains horizontal and passes the package to the distribution conveyor on the lower level of the system. To track packages along the distribution conveyor, the PLC uses an encoder. This is used to determine when to shunt each package into one of the 3 discharge chutes. The distribution conveyor has 3 types of diverters which shunt the packages into the chutes. There's a pusher, there's a bow arm sorter, and there's a 2-axis pick and place manipulator. So these are 3 of a number of types of diverters that are used in industry today. So now that I've described the overall operation, let's watch a short video so you can actually see the device in action. And before I start the video, let me point out a couple of things. First of all, you'll see on the screen that there are 2 PC screens. There's one on the left that shows a Fault Pro screen. That's actually a fault insertion software that we've developed that inserts faults into the system to teach troubleshooting, and I'll talk more about that a little later. And then on the right screen, you'll see a picture of the 3D picture of the workstation, and that is actually one of the screens from the warehouse control software that actually controls the system. And then finally, you'll notice over on the right-hand side, the control unit, and it's a standard industry enclosure with lockout tagout. It's got a disconnect switch, has a control start stop, and other safety devices that are typical of what you found in industry. So we've tried to create a system that looks and feels as much like people are going to see when they actually go out on the job. So let's play the video, and as you'll see it panning across, you'll see a few guards. Each of these guards has a safety switch on it so that if it's removed, the system stops, just like you'd find in industry. And then we're going to start over here on the right, and you'll see packages being placed on the induction roller conveyor, and you can see the gap being set. They're now going down the belt conveyor, being scanned by the barcode reader. If it's a good scan, they stay on the vertical sorter conveyor and get passed to the conveyor on the back, which is the distribution conveyor. If it's a bad scan, it goes up to the recirculation conveyor and then comes over, gets stopped at a rework station. In this case, it's a barcode label that was on the flipped over, so it was replaced or fixed and then operated and I'm going to stop the video for just a second. And so the gravity slide allows the boxes or packages to rejoin the induction belt conveyor, get rescanned, and then if they're good scans, they come over on the conveyor that you're seeing here, and you can see 3 chutes, and each of the chutes has a different type of sorter or diverter that I mentioned, and what we're seeing is the actual operation of those various diverters. So this is the 2-axis pick and place, and the one on the right was the bow arm sorter. Now we're seeing somebody operate or navigate through some of the screens of the warehouse control software. You can see it's a touch screen display, so it's very easy to use. And then they operated the Fault Pro software, and that's where they would go into a troubleshooting exercise. So the system, I think, is really easy to use, but the learning that it provides is truly extensive. So if you examine SkillBoss up close, you'll notice that it has a wide array of components. And as I mentioned earlier, the purpose is to make sure that individuals are being exposed to as many different components as they're going to see on any kind of device that they might find in supply chain automation. And to give some examples that are noted here on the screen, we have a variety of input sensors, magnetic read sensors, inductive sensor, 3 types of photoelectric sensors, even a limit switch. We have 3 types of AC and DC motors. The PLC has discrete and analog I/O, a high-speed counter, Ethernet. In the mechanical area, we have different types of bearings, belts, chains, a variety of mechanical components that they're going to see when they go out into any type of distribution center. And as I mentioned previously, the warehouse control software, these are some examples of screens of what it has, and it is capable of monitoring and controlling the entire system. And we actually developed this in-house because they're generally matched to the specific system they're used for. But we looked at a lot of different systems across the country with the help of our industry advisors and actually developed a software that is a combination of warehouse management software, warehouse control software, and conveyor control software. And actually all 3 of these are often used in distribution centers to control the entire system. And so it's really a very, very powerful system with alarms and order entry and many different types of operations. So up to this point, I've shown you the elements of SkillBoss that make it operate. What I'd like to do now is talk about the part of the system that's designed to make it not operate. And this is actually the most important feature of the system because it enables individuals to learn and assess their troubleshooting skills. To accomplish this objective, we've used a computer-based fault insertion system called Fault Pro. And Fault Pro consists of an electronic circuit board and software that inserts faults into the system, and it tracks the student's troubleshooting activity. And we've actually created over 50 different faults in the SkillBoss system for Fault Pro to be able to insert. And you can see examples on the left of some of the types of faults. It can put faults into sensors and valves, motors, controllers, the scanner, the VFD, pretty much all parts of the system. And the goal is to make sure that it presents the symptoms with more than one possible cause so students have a real-life troubleshooting experience. So to start a troubleshooting exercise, students select from a menu tree like you see on the Fault Pro screen on the right side of this slide, and they select from 2 different modes. One mode is a single fault mode and the other is a random fault mode. And you can see the two buttons up here on the right side of that screen that identify those. So in the single fault mode, faults are inserted manually by the student to learn the behavior and how to test for each fault. And then in the random fault mode, faults are inserted automatically by the software and the student is challenged to locate the specific fault. Students don't know what the fault that is that's been inserted by the computer, so they have to use a troubleshooting methodology starting with symptom identification to isolate the problem to the specific fault. And in this random fault mode, the Fault Pro software tracks the troubleshooting process, including the number of correct and incorrect answers and time to solve. So using a computerized method of inserting faults like this has a lot of benefits. One, and most obvious is that you're solving world problems, that you're getting a rich troubleshooting experience where the students are doing it firsthand. They're not just having a teacher demonstrate a few examples. Second advantage, I think, is that it's safe. We've designed it so that it won't hurt the student and it won't hurt the equipment. And a lot of times when people put faults into systems, they easily tear up wiring or do something that creates more problems than they were expecting. Thirdly, it's automated. Students can use both modes without teacher intervention. So teachers don't have to babysit the student when they're learning or testing the troubleshooting process. And then finally, with the system actually creates a database. So it's a record of the students' work that they've done, and so that it can be used to try and help improve students' troubleshooting skills. Being good at troubleshooting isn't just about being able to find a fault. It's about being able to do it quickly. And probably that's the most important thing, is that if you can't do it in a short amount of time, it gets to be very expensive for the distribution center. And this database gives teachers a way to measure that so that they can help students find the path to being able to master their troubleshooting process. So as you might expect, teachers have much to learn to teach and certify individuals in the CT-SCA certifications and SkillBoss. To make it a success, we've developed a master teacher training course. And as Neil mentioned earlier, it's initially going to be held in Amatrol in Indiana starting in the fall, but the goal is to get it pushed out into the various regions. And the course is going to be designed to teach teachers how to implement the certification, how to work with the online courses, and to become thoroughly familiar with the SkillBoss logistics device. It's a week-long course with pre-work using the online courses, so we, with the goal that they can come to class already being able to focus on the hands-on part of the training, which is the one thing that they can't do anywhere else. So that's what I have to share about SkillBoss Logistics. If you have any questions, we will have a Q&A session here very shortly following Steve's wrap-up. And after the webinar, if you want to reach out to me, here's my email address. And now I'd like to turn it back to Steve to wrap up. Steve?